The next question is June 07, paper 2. So you can see these are all quite short, and the reason is because they're part of something else, maybe a motion question or something like that. A ball is dropped from a height, so it bounces on a smooth concrete floor. The height h from which it is dropped is measured. The height y of the first bounce is also measured. The ball is dropped from the same height a number of times, and the height y is measured in each case. The average value of y is calculated, and the results are shown on the table. Why is it good experimental practice to repeat measurements and to take an average? So you can say something there about the fact that it is more accurate or more reliable, and that will easily get you your mark. And I'm just realising you can't really see that. So more accurate or more reliable. It then tells you the mass of the ball is 0.05 kilograms. Calculate the potential energy converted into other forms when the ball is dropped from a height of 0.6 metres, but it only bounces to the height of 0.8 metres. So it is this amount of gravitational potential energy before. It only reaches or only gains this amount of gravitational potential after. So it's the difference between the gravitational potentials of these two which will give you your energy loss or the energy that's converted to other forms. So we have to calculate GPE before, and that's equal to mgh, which is equal to 0.05. G is always got a value of 10 on the earth, and it's multiplied by 0.6 metres, and that gives you 0.3 joules. Then the GPE after is equal again to mgh, and that's equal to 0.05 multiplied by 10 multiplied by 0.48, and then that's equal to 0.24 joules. And then the last part is just calculating how much energy is lost, and so that's 0.3 minus 0.24, and the answer is 0.06 joules. 0.06 joules. And so you get 1 mark for your answer, and you get 1 mark for calculating the potential energy before, and 1 mark for calculating it afterwards. The next question just continues from this, so we'll hold it here in case we need to look at it again. A graph of potential energy at the top of the first bounce is down the left hand side there, and it's plotted against the initial potential energy, which is along the bottom there. The graph is a straight line that passes through the origin. What does the graph tell you about the ratio, the potential energy of the top bounce divided by the initial potential energy? Now that's a little bit off-putting the way that's worded there, but what they're meaning is what happens whenever you divide this number by that number each time for the line, and you can see it has to give you a constant value if you're going to get a nice straight line. So you could even check that out. You could have a wee look there at 0.4 divided by 0.5, and then up here you have roughly 0.8 divided by 1 there, and it's the same ratio. 0.4 over 0.5 is 80% or an eighth, or sorry, 8/10, whereas or 4/5, and 0.8 over 1 is the same. It's going to be 80% or 4/5 or 0.8. So what does it tell you about the ratio? And it tells you the ratio is always constant. And I would put in there, as it is a straight line, as it is a straight line through the origin. You'd obviously write this out properly. I'm just writing it in shorthand. What percentage of the initial potential energy is always converted into heat and sound? So a minute ago we just talked about this ratio idea, and the ratio there of how much is converted from the initial potential energy into the final is roughly about 0.8 there. So I'll just do that calculation here. If you take, say, that value there, and I'm choosing a value where we can see that it obviously goes through those two corners there of that square, or that corner of the square, and so it's roughly 0.4 over 0.5. So 0.4 over 0.5 is what is converted, and that's giving you 0.8 or 80%. You can check that out again up here. You can see 0.8 over 1 is obviously 0.8 or 80%. And then you have to take that away from 100%, or you have to work out what's lost. So energy lost must be equal to 1 minus 0.8, and that gives you 0.2, or it has to be expressed in a percentage, so it's 20%. So the answer there is 20%. And so you get an answer, a tick for just 20%. There's no working out marks awarded there.